Okay, in this video I'm going to show you how to make a guard ray or a light shaft, whatever it's called, and with the fades and everything, so it's functioning as it should. But as with any other videos so far, I would like to make sure that we understand the basics of things. So what I'm going to do is I'm going to go step by step, but I also want to make sure that you in fact understand some of the nodes. So if you already know all of these nodes or you are confident, you can skip ahead just to see how I've done it. If you don't know everything, I will just briefly explain some of the logic, okay? So we're going to start with this one. So that's the basic one. And to get the basic one, I've used a time, a parameter. If you remember, you press down 1, you right click and you convert to a parameter. And I've just named it speed. I've then multiplied it and I'm using a penner to move it, okay? And I have a texture sample, and in each channel I have a grayscale of these lines basically, and I'm combining it together using multiply. And I'm dividing it with an eye adaption, because without the eye adaption I won't see it. So basically what the eye adaption does, if it does make it visible because of the physical correct exposure that I'm doing. You could add a parameter if you wanted to, and you could add it as intensity as well if you want to increase it more higher or make it a bit different. That's perfectly fine as well. Okay, so time, if we were to look at the description, it says that the time node is used to add the passage of time to materials such as a penner, cuisine, or other time dependent operation, which is essentially what we're doing. We're adding time into the penner, okay, and we're moving it by 0.1. And then we have speed, which is basically adjusting the speed on top of the default penner speed, so we can make it faster or slower. You don't need the speed, but we have added it. So, okay. You could in theory also just have it like this, and it would technically work fine as well. But as you can see, you're losing control of the speed, because there's different things happening here. So to control it and make sure it's working as intended, we have the speed parameter as well to have a little bit of control. Okay, now there are obviously problems here. You can see the edge here, and that's not necessarily something we want. So we move over to the second node, or the second version, which is an updated version. And in this version we have something called a gradient fall off. We are using a power, a breakout flow to comparison, a component, the texture coordinate of everything, and we're using a parameter to control the value of the fall off, okay, the intensity. So if I go here and I type in 10, it's gonna calculate the surrounding area, and therefore you will not see it. So we need to make sure that the range is somewhat nearby, okay? So in simple terms, the TexCoordinate provides the UV coordinates, so we have U and V of the texture applied here. So think of it as a way to map a 2D texture onto a 3D surface, the plane in our case. The breakout flow to component node, this splits the UV coordinates from the TexCoordinate into two separate float values, U and V. This will allow us to manipulate each component individually, which is why we are having red and green, and we are basically using only one of them. In theory, we could use both if we wanted to. We didn't necessarily have to use. We could technically just made it simple like this. but then you have these colors that comes from all of the information that's there. And because we want the gradient information, we want to pull off the information from the textures, we want to have this channel there. The power node raises a base value to the power of an exponent. So in our case, the base value is the UV coordinate, and the exponent is controlled by our parameter here, which we have named falloff. So by adjusting this exponent, we create the gradient effect. Okay, so this parameter is the variable we use to adjust control the power node. We can fine tune the falloff of the laugh jet, making it sharper or softer. So in simple terms, we are using the UV coordinate of the texture. We are breaking them into two components, and then we're using those components in a power function to create a gradient effect on the light shaft. Okay, and that's why we don't have the edges anymore on the hair. Okay, it's just fading. So that's what's happening there. Okay, the next step, this is by way, if you don't know, this is a reroute, and I'm using reroutes to speed up some of the stuff. Let's put this here. So we go to number 3, and on the number 3 we are solving another problem, which is the scene depth. To give you an example, let me just go back here and do apply, and I think I should be able to show you the second problem, or there's multiple problem. You see how this one is having the edges when the character is moving around, and that's what we are trying to do here. We are essentially stating that we want to add a calculation so we get some kind of fade on the character too. Now, I was going to show this method, but luckily I don't have to, and I don't have to explain it to you, because I found there is something called depth fade and an edge depth, which is the parameter added to the fade distance, and all it does is is calculating the depth fade of the cylinder or the character and the surface of the light shaft. Okay, now if you want to understand, so this node is basically all of this. Now, in case that doesn't make sense, because I don't think it did, which is why I've kept it here, I'll explain it very simply what this is doing. Okay, so these two, or this depth fade. So the scene depth node, which you see here, this node gives you a distance from the camera to every point in the scene. It's like a map showing how far away each part of your scene is. The pixel depth, this node provides the distance from the camera to the surface of the object that we are trying to affect. So think of it as a checking how far the object surface is from the camera. Okay. And the substract node, which I've mentioned in the previous video, this node takes two inputs and subtracts them from each other. Okay, so in our case, it's subtracting the pixel depth from the scene depth, and this determines how far our object surface is from other objects behind it. The divide node, we're using this is taking the result of the subtraction, so how far the object surface is from other objects, and we're dividing it by the edge depth parameter, and the edge depth parameter lets us control the fade effect strength. Okay, so when an object enters the light shaft, this setup calculates how deep it is in the scene, and it applies a fade effect based on the distance. And the edge depth parameter is the one that's adjusting it, how quickly or slowly this fade happens. And this creates the smooth transition as objects moves through the light shaft. Okay, so essentially if I went down here and I went on 0, this is the edge, and I go to 100, okay, 50, okay. So you can adjust it accordingly to make it work as you want, right? So that's what that's doing. So this is basically a collection of this, or Unreal made this because, well, we all do it a lot apparently, so they made it easy. Okay. The second problem is, let me just move this down. We also want the camera to fade, so when we are coming close, that it is fading everywhere correctly and it doesn't pop. For that, we have something also pretty simple. We have something we added here simply called the camera depth fade. And essentially what it does, it fades it. So you don't see that pop. It's just fading it in and out based on the fade length and the fade offset, which is basically the distance from the camera and this particular object that has this. Okay. Lastly, we obviously want to have a bit of Fresnel, which I won't go into too much detail, to be honest. I'll do that in the course itself, the main course. But basically what I'm doing, I'm using a Fresnel to calculate the angle. So when you're going on one side or the other side, it's fading as you need, right? Because otherwise you wouldn't see the fade correctly, or the brightness would be the same, or the darkness would be the same. So this ensures that it's all looking nice. I've also turned two-sided, also added a color to the calculation in case you wanted to change color. And I have also, just so you remember, you need it to be additive and unlit. I didn't mention that because at the moment I'm just assuming you know this. If you didn't, now you know. And that's how you get a pretty straightforward beginning of a light shaft, which you can obviously make more complicated if you need to. Now, again, keep an eye out. If you like this, you go to www.lightingbot.com or www.academyoftalent.com. This version will be free also on lightingbot.com, but any updates will be in the course itself, so you need to sign up for any more detailed explanations or tips and tricks that's beyond what I'm doing here on YouTube. Okay, so thanks for watching and have a good day.